What's going on, guys? Mr. Garcia here, back with another video, this time discussing still Module 4, but we're talking about probability. So only some big key things about probability to know about. Your basic simple and independent probability, your fundamental counting principle, and then your dependent with and without replacement. So let's jump into this first section. Biggest thing about probability is this part. And we'll use this as well with your dependent, by the way. But probability, just like by definition, is like how likely is something going to happen. Independent means the multiple events do not affect each other. Like if I am flipping a coin or rolling a dice, the whatever happens with the coin is not going to affect the dice and vice versa. If it's not independent, it's dependent. So the first part changes the options for the second part. Now, probability just says, hey, a probability something happens. So what is something you want to happen, the favorable outcome, over the total possible outcomes, the total outcomes. So if you have a bag with 5 red marbles and 3 blue marbles, you select one of them at random. What's the probability you get blue? So the idea here is you're looking at two things. You want a blue marble, and how many total marbles are you getting? So there are 5 red and 3 blue in the bag. So there's 8 total, and you really want a blue marble. So the probability you get a blue is just 3 out of 8. Now, whenever you have multiple things happening, multiple draws, multiple events, we'll just multiply each thing together. For example, you got a cube. Cube has 6 sides, and you roll it twice. That twice tells me I'm going to be multiplying 2 things together. There are 2 events happening. The first event and the second event, they both are talking about rolling a 6 both times. Now, that means ideally, I want a number 6. And how many total sides are there possible? Well, I mean, a cube has 6 sides, right? So that's the total amount of sides. And a 6 only appears once on the cube. So 1 6 for the first roll, and then still 1 6 for the second roll. If you forgot to multiply fractions, you just multiply straight across. 1 times 1 is 1. 6 times 6 is 36. Same idea here. If you were doing this 3 times, 4 times, 5 times, you're just multiplying each event together. I will say, maybe something to jump off of this. If we then said, and getting a heads or getting tails, and then getting tails, right? You would still have these 2 events, and you also have this third event. You would just then at that point attach another fraction, maybe like 1 over 2. There's only 2 options, heads or tails, and you want tails, right? So independent events, one event doesn't affect the other. Dependent, one event does affect the other. Now with dependent, there is 2 big keywords we need to know: with and without replacement. We're still going to multiply, okay? We're still multiplying. But what we're multiplying depends really on what the scenario says. So, for example, if we look at something like number 3 versus something like number 4, right? The biggest key word here, apart from the numbers, is replace and without replacement. In this scenario, you got 3 red marbles, 5 blue marbles, very similar here. You draw a marble, replace, and then draw another one. That means if you place yourself in that scenario, you have a bag of marbles before you. You draw one of them, and then you put it back in the bag. On the second draw, the number of marbles in the bag has not changed. They are still, in this case, 8. So we're still looking at 2 events, the first draw and the second draw, and we still are going to multiply them together. On the first draw, you have 8 marbles. On the second draw, you still have 8 marbles. You replaced it. Now, you always treat this second draw as if you did what you needed to do. Like, it's 3 out of 8 for the red. It's going to be 3 out of 8 for the red as well. We're going to assume that we're going to draw red on both attempts. So, we wanted the probability of 2 draws. We drew the red. We replaced it and put it back in the bag. So now there's still 3 out of 8. 3 times 3 is 9. 8 times 8 is 64. So when you read number 4, similar scenario, 2 events. You're drawing 2 marbles. So first draw, second draw. On the first draw, you want red. So you have 6 red and 10 and 4 green. So they have 10 total marbles. And you want a red. On your second draw, notice the key word, without replacement. So you drew the first marble, and then you kept it out of the bag. You assume you drew a red marble. So 1, there is definitely 1 less marble. And 2, there's a red marble that's missing. 5 out of 9 on the second attempt. You wanted them both to be red. You notice that without replacement said it stayed outside the bag. That's why it went down from 1. In this case, you still multiply. 6 times 5 is 30. 10 times 9 is 90. Simplify this or do that trick we mentioned in the last video. If you struggle with simplifying fractions, watch the last video. We gave you a trick on how to make sure you get the correct answer every single time. Divide by 30. Divide by 30. 1 over 3 in this case. If you haven't already, right, try number 5. Good question. Deck has 10 cards, numbers 1 through 10. 2 cards are drawn without replacement. What's the probability both cards show an even number? Ooh. Okay, so first draw and second draw. Well, we have 10 cards. And if in a deck of cards, numbers 1 through 10, 5 of those numbers are even. So 5 of those numbers. Keyword here is without replacement. That means on that second draw, there's 1 less card and there's 1 less even card specifically. So 5 times 4 is 20. 10 times 9 is 90. They both end at 0, so divided by 10. So 2 over 9. Last part is talking about, there's still more questions. But this one part here is talking about counting principle. And this last part is still talking about probability, but just in a different way. All right. Counting principle just basically says this. If you have a bunch of options and you want to figure out what is the total amount of options, we just multiply the number of choices together. So you got a restaurant that offers 3 different sandwiches and 4 choices of drinks. How many different meal combinations? So if you got sandwich A and drink A versus sandwich A and drink B, sandwich A and drink C, so on and so forth. We just multiply all the different options. You got 3 sandwich options, 4 drink options. Therefore, you have 12 options altogether. Same idea here. A license plate consists of 2 letters followed by 1 digit. Okay? So you got 3 parts for a license plate. 2 letters. And then you got 1 digit. So 1 number 0 through 9. If letters and digits may repeat, how many different plates are possible? Well, what are the choices? The choices for letter are 26. It can repeat. So the choices for the second letter are also 26. There are 26 letters in the alphabet. Digits, as in 0 through 9. So notice 0 counts as a number. So then we have 10 different options for digits. So 26 times 26 times 10 does work out to be 6,760. Last 2 questions. If you haven't already, definitely try them out. Try your best with them. See how you can work them out. And double check on the video for the answers. If you did it correctly, 7 will be B. And number 8 would be B as well. All right, talking about the answers now. Based on the table above, which statement is true regarding the probabilities? So we got event outcome A, B, C, and D. And each of them has some probabilities. So A is more likely to occur than D. B is most likely to occur of all of them. A and C combined have a lower probability. And D is twice as likely to occur as C. Well, fractions are weird. And honestly, with fractions, if you want to just turn them into a decimal, that might be easiest. So like 1 divided by 12 is 0.083. 1 divided by 3, 0.333. I'm doing 3 decimal places for the sake of accuracy. 1 divided by 4 is 0.25. And 1 divided by 6 is 0.167. So on this, it's a little bit easier now to see which number is bigger or smaller than the other. For example, clearly A is the smallest of all the three. So answer choice A, outcome A is more likely to occur than D. Definitely not. So it can't be A. I know I just said B was the answer, mainly because look, B is 0.3 repeating. That's definitely bigger than all the other ones. Let's just double check. A and C combined have a lower probability than B. Well, A and C, A is 0.083. And C is 0.25. Add them together, and that actually works out to be 0.383. So they don't have a lower probability than B. They actually have the same. Outcome D is twice as likely to happen as outcome C. So D is 0.167. It's twice as likely. I mean, you can probably guess off the bat it's not going to be that. But in that case, actually, 0.167 actually is bigger. Oh, I think they messed up. I don't think they meant to, because 0.167 divided times 2 is 0.334. Yep, I think they made a mistake. I think they should have flipped it. No, yeah, D is an answer also. This is by accident. They didn't mean to also have this as an answer choice. So this is by accident. Ignore that question. If you're in my current TSI course, I'm going to change that real quick on this stuff. That's funny. All right, cool. Last question here. Frequency table shows a number of results of games played by two different teams. But there's actually not any numbers, just a bunch of letters. So in this case, what is the expression for the probability that a game selected at random from Team Beta was not a win? Well, if you're looking at not a win, that means you're looking at a loss or a tie. And also, we're looking for Team Beta, so I don't really care about anything from Team Alpha. So if anything has A, B, or C, I don't need that. So just enter option C in this case. Still the same thing as last time, right? We had the total amount of different games, which in this case are the win, losses, and ties, and the favorable outcome, or the outcome that we want to happen, are your losses and ties. Well, the outcome are all the games added up together. I know there's not numbers here, but if there was numbers, you would just add up all those numbers together. Same thing for the losses and ties. You would add up all those numbers together. So in this case, Y plus Z would be the correct answer, as in B would be the correct answer. Thank you so much for watching. If you have any more questions, be sure to shoot me an email. Put it down in the comment section below. If not, thanks so much for watching. Hope you have a great rest of your day. And as always, go Mavericks.